Today's one is a very exciting session. I have tuned quite a lot of things for a period of 20 years, uh, ranging from typical web or mobile applications all the way till big data related applications. I have consolidated some of the common techniques which I have used over a period of time, and I came up with a curriculum. Everything will be available in GitHub. I'll be sharing the details of GitHub repository uh, in the description of the video after this session. For today's session, I don't suggest you to perform live tasks because there's a lot of material and it will be overwhelming. I would highly recommend you to follow this session. And then if you have any questions, you can ask in the chat. However, I would highly recommend you to go through this video multiple times so that you really understand the thought process behind performance tuning, not just learning some of the common techniques. Now, I am planning to consolidate all our data engineering courses along with the material related to SQL performance tuning under one repository, which I have launched recently. It is nothing but uh, data engineering courses. This is the repository where we'll be publishing all the content. It is still in progress. You can see I have just started 3 days ago, and I'll be fixing this over a period of time. And if you look at this, there is something called as SQL performance tuning, and you should be able to see all the material here. Uh, this README in the main folder of SQL performance tuning will give you the overall agenda of this session. However, still there are few things which I have to update. I'm also publishing content in Medium along with Git repository, and there are few challenges which I'm facing. Git repository is a little bit behind than what I am going to cover today, but I will fix all the gaps in the Git repository in next couple of days, and I'll be providing the link to Git repository in the description, and you can follow it, and you should be good to go. I'm also publishing the content in several Medium articles. I thought of writing in one Medium article, which I have already published, but it is too big and it is not a good practice. Hence, I'm going to break down that big mammoth Medium article into 11 to 12 articles, and I'll be publishing in Medium also. Medium and Git more or less will have same content. Depending upon your preference, you can choose whatever you want. Now, what is the agenda for the course, right? So there are quite a few things which I'm going to cover. There will be a lot on explain plans. Explain plans will be used in several places in the course, but at a higher level, we will see these things. We'll start with setting up a Postgres database in GCP. Then we will get into the details about understanding execution plans. Then we'll talk about indexing foreign key fields. This is the most basic performance tuning technique which you can consider, and it will always work. Means there are quite a lot of times where people miss this very fundamental concept, and you can definitely feel the magic by just indexing appropriate fields. So we'll be talking about that briefly. Then there is something called as SARGable, such argumentable queries. So we'll actually talk about how to index based on the search patterns, SARGable patterns. Then we'll also talk about some of the pitfalls about indexing. We'll talk about over indexing and how to maintain the indexes over a period of time. One of the common performance issue is ill-written queries. And there are a couple of scenarios where I see even experienced professionals write bad queries. One of them is using subqueries in place of joins, and another one is not writing ranking queries appropriately. When I give exercise in interviews or even to my students in the courses about get me the top 5 performing students, typically they compute the total, sort the data in descending order, and use limit. And that is not appropriate. And there are other ways also where people end up writing bad queries when it comes to ranking. So we'll also talk about those in joins versus subqueries and also optimizing ranking queries. Also, we'll talk about table partitioning and partition pruning. We'll also talk about importance of using appropriate data types. And towards the end, we will actually talk about bulk loading strategies and also the where data should be processed. Should it be processed in database or should it be processed in application layer? And also how to uh, take care of improving the performance by using something called as DYP strategy. DYP stands for Do Yourself Parallelism. And I have fixed quite a lot of performance issues using that. From days, the performance have came down to minutes and hours just by using this DYP strategy. We'll talk about in detail when we get there. So this is the agenda which we are going to talk about. And one more thing which I wanted to highlight before we actually get into today's agenda is we are also planning to run a live workshop on data modeling. Data modeling is one topic where live workshops make sense. Just self-paced videos is very boring when it comes to data modeling. We wanted to run live workshops around data modeling. We'll actually provide the link for a Google form in the description after this. If you are interested to attend the live workshop around data modeling, feel free to do so. First, let me quickly walk you through the agenda of that, and then we'll take it forward. Let me open the document. So this live workshop is relevant to anyone who want to learn data modeling. It is not for not just for data engineers. It is meant for full stack developers, Java developers, whoever wanted to develop any database driven applications. This live workshop adds a lot of value. Let me show you the details here. This is the high level agenda. Sorry, the font is not very user friendly because this is we have come up with this in a rush, but we'll actually share the Google form, and the topics which will be covered will be foundations of data modeling, exploring data models, deep dive into normalization and also denormalization. This will happen over 2 weekends because it takes anywhere between 12 hours to 16 hours. We'll also talk about foundations of data warehousing and dimensional modeling. So these four topics are more relevant for application developers, but application developers these days also should have idea about uh, other side of it also, because application developers will end up building large scale analytics applications in this data driven world. Hence, having knowledge about analytics type of data modeling is also very, very important. For that reason, if application developers are interested about modeling in data warehousing, then the advanced section will cover. It will talk about NoSQL data modeling. It will talk about best practices and pitfalls. And also there will be a capstone project where we'll give an exercise. You have to come up with a data model. We'll give a couple of weeks time. We'll review and we'll share the feedback. So this is the overall agenda. The cost will be definitely be under $100, as it is a first workshop which we are going to conduct. We haven't finalized the price yet. We'll let you know. Feel free to look at the description, probably starting from tomorrow, or just comment on YouTube or send an email to support@itversity.com. We'll share the details as and when we are ready with the collateral to sign up to get the enrollments to the course. So just want to highlight about this. If you are interested to learn data modeling from an expert, this is the live workshop to go. The session will be conducted by Sharath Sagi, who is a principal data engineer in a large scale tech firm with 15 plus years of experience. You will definitely love it. And it is also curated by me. So we took care of all those edge case scenarios where people might end up going wrong. You will definitely love the workshop. That being said, now before going back to the agenda, just wanted to solicit your support. It will be great if you can actually provide the feedback about this session. If you learn something, if you can actually share the details about what you have learned in this session in the form of comments, it will help a lot. Also, if you like the overall agenda of the content and the way it is delivered, make sure to click on the like button. and also make sure to share with your friends so that they can also pick the performance tuning skills. And if you haven't subscribed to our channel yet, make sure to subscribe so that you get notified whenever we provide the content like this or we publish the content like this. To get the notification, you need to keep in mind that you have to hit on bell icon. Make sure to hit on bell icon so that you are notified. That being said, now let's get to the first topic, which is nothing but setting up a Postgres database. So as I have mentioned to you earlier, the content in Git repository is not up to date. I'll open the Medium article and then I'll walk you through details about setting up Postgres database, and then I'll take it forward. And in next couple of days, we'll make sure uh, the entire Git repository is updated with the correct instructions. With the Medium, we are facing few challenges because we are publishing a lot of content in under my account. Hence, we are not able to publish even the articles are ready. Over next 1 week, all the articles will be published in Medium as well, and we will share the details with you in YouTube description for both Medium as well as the main page of the Git repository. Now, just give me a moment. Let me open the first Medium article, which is about setting up the database, and then we will take it forward. So first we need to have a database so that we can actually experiment with performance tuning strategies. For that purpose, we are going to set up a Postgres database using GCP. Why we are choosing GCP? It is easily accessible cloud platform, and we can shut it down once we are done with it. I don't want to get into too many details here. However, if you wanted to get started with GCP, if you are new, you just have to visit cloud.google.com. Then you can click on get started for free. You might have to sign up if you don't have the account. Once you sign up, you can receive $300 in free credits for exploring various GCP services. The credits are valid for 3 months. Hence, you will have ample time to experiment with respect to performance tuning. However, I recommend you to stop the database if you are planning to take break in between when you go ahead and practice, uh, so that you don't run out of the $300 credit quickly. And I would highly recommend you to complete the whole exercise with respect to performance tuning over a weekend so that you feel confident by the time you are done with your weekend. It can be over a weekend or probably over a week by spending like half an hour to 1 hour every day. So you can pick one of those strategies and make sure you perform hands-on wherever it is relevant. Now, when it comes to the performance tuning strategies, these are generic strategies, even though they are going to be demonstrated using PostgreSQL, be it Oracle or SQL Server or MySQL, even with respect to data warehouse databases like Teradata, BigQuery, Redshift. Most of these strategies can be leveraged. And also keep in mind the content is not just for data engineers, even full stack developers, Java backend engineers, Python backend engineers. You guys also can use many of these strategies without a miss. This is a generic content, and you should be able to use it against any database. You just have to adapt to the database which you are going to use, and then you can take it forward. These are general principles, but for the demo purpose, we are using Postgres. In future, me and Sharath are working on quite a few workshops which are specific to a given database. So there will be a performance tuning workshop on BigQuery, there will be a performance tuning workshop on Redshift, there will be a performance tuning workshop on Databricks. Like that, for all major databases, we will use our past experience and we will cover all the important performance tuning scenarios. That being said, for now, just keep in mind that it is generic. We are just using Postgres for our convenience, and these techniques can be used on any database by any IT professional. That being said, uh, let's quickly go ahead and set up. These are the steps which you are supposed to follow. First, you have to set up GCP project. Then you have to create Postgres instance. Then you need to take care of network configuration so that you can connect it to database. Then you just have to ensure you can connect to database by just uh, connecting to the database. Okay. So that being said, I'll be using Mac terminal, but if you are using Windows, you can use PowerShell or Git Bash Whatever is your preferred tool, you can use, and you can take it forward. Most of the commands will run as is. You don't need to change many things, but you might have to change certain things based on your preferences. Probably the names you might want to use something else than my Postgres instance, or you might already have a instance like this, hence you might want to change. When it comes to password also, you might want to change the password to your preferred one rather than whatever I'm going to use, right? So depending upon your preference, you can choose and then you can take it forward. And here, once you sign up for Google Cloud, you don't need to go to Google Cloud Console again. Everything can be run using CLI. Just go ahead and run the commands which I'm going to cover here, and you are good to go. So the first one is you need to make sure you are logged in uh, uh, into your Google Cloud account using command line. For that purpose, you have to use this command gcloud auth login. Then it will open up this page. You just have to click on the relevant email account and then click on continue. Then hello. Now you are authenticated. You should see this message. You are now authenticated with the gcloud CLI. Once you are authenticated, then the next step is you have to configure the relevant project. What is the project? Let me quickly open the browser and explain so that it is clear for you. So this is what his project is. You can expand and you can see all the projects. You have to choose the relevant project and take it forward if you wanted to use console. The way you choose here, you can also choose from the command. So for that purpose, you can use this command, gcloud config set project. As I have already configured to work against a specific project, I can actually use get command to confirm whether I am attached to the correct project or not. And you can see I am attached to the ITversity R&D. This is the one which I want to attach to, so I am good to go. So gcloud config set project ID will make sure your gcloud is configured against the intended project. Whatever project you have configured with the $300 credit, that is what is supposed to be used here. Then you have to enable Cloud SQL APIs. For that purpose, you should be able to use this command. You can also take care of this using web console, but this is pretty straightforward. Again, the commands are available in the material. You just follow and take care, because this is not actual GCP course. We are not getting into all the details. You just quickly set up the database and you are good to go. Once it is done, then you can use this command. So here I'll be naming it as performance tuning demo or perf demo. Let me say perf demo instance. The database version is Postgres 15, CPU is 1, close to 4 GB memory. This is the region. You might have to change the region depending upon your account. In my case, this is the region. If you're not sure about the region, again, you can actually go to the browser. Okay. And then somewhere it should show the region. Where is it? Let me click on this. I forgot how we can get the region. There might be commands also. You can use the command and you should be able to get the region. All you need to keep in mind is you have to use the appropriate region. Otherwise, it will not work. Okay. Probably you can say gcloud config get region and you might be able to get the region which you are supposed to, where your project is. And you might have to explicitly specify like this. Then storage size is storage size is 10 GB and type is SSD. And we are saying auto increase. However, we will not be reaching this limit. Hence, we are good to go. You can also disable auto increase if you want. Now let me hit enter. You can see it is creating Cloud SQL instance for Postgres 15. Here the version is Postgres 15. Hence, the database will be set up using Postgres 15 with the instance ID perf demo instance. Let's wait until this is run. After that, the next step is we need to set the password to the default super user of Postgres, which is nothing but Postgres itself. Once we set the password or default password for Postgres user, you should be able to connect to the database without much challenges. We also might have to take care of network configuration so that we can connect to the database in GCP, which is set up using Cloud SQL without any issues. You will understand what I'm talking about once the database is up and running. Let's wait until it is fully up, then we'll take it forward. While it is coming up, let me walk you through the structure of the Git repository. That way it is clear for you and you will not be end up wasting your time in searching for the material. Let me go to the Git repository here. If you look at this Git repository, I have several other folders also, data, setup and all. Setup have quite a few SQL scripts you can see here. So once the database is up and running, we'll be creating the tables using this. So there are a bunch of tables which you are going to create, and we'll be using this script to load the data. So we'll be populating all the tables, and you can see we are using functions like generate series and all to just generate series of numbers, and also random to generate random numbers for certain fields. So this will take care of populating data into all the tables. We'll be using these tables quite a bit. On top of setup, we also have data folder. You can see there are a couple of folders, retail DB and Toyota sales. We'll be using these datasets also when it comes to tuning the performance. I attempted to make it as realistic as possible. And if you really understand the gist of it, you should be able to apply this knowledge as a fresher or even as an experienced professional. You can also build a narrative when you face the interviews as a fresher, saying you have experimented quite a lot with performance tuning and take it forward. For experienced professionals, you might have implemented some of these things. This will help you as a cheat sheet to explain some of the common scenarios when it comes to performance tuning. When you introduce yourself, if you mention that you are an expert when it comes to performance tuning, the possibility of cracking the interviews will be higher, provided you are able to support your statement or your narration. So performance tuning definitely excite the interviewer, and the probability of cracking the interview will be much higher if you talk about some of the standard performance tuning scenarios or even out of the box solutions which you have come up with based on your projects. You should definitely talk about performance tuning in the interviews, especially as an experienced professional. Even as a fresher, if you can talk about performance tuning a bit, you can earn some brownie points. That being said, now the database is up and running. Let's go back to the material. Let me close this. It is not required. Let me open the material. Where is the material, medium material? Yeah, this is the one. It is on the other screen. You will not be able to see. Now we have to set the password. Let me copy the command. Let me paste. So this is where we have to set the password. I have to fix the instance name also. So let me actually replace this with perf demo instance. And password, let me say perf demo 123. Now it is updating the database. The user Postgres can be accessed with perf demo 123 as password. However, you need to get the IP address of this, and then you have to use it to connect. The way you can get the IP address is like this. You can say gcloud SQL instances, then list. You can see there are two of them. This is the my Postgres instance, which I have used to build the material. This is the one which is just provisioned. Perf demo instance and IP address is this one. So we need this IP address. The way you can get the IP address is by using this command, gcloud SQL instances list. Now, first we need to make sure to confirm whether we can validate this or not. For that, we should be able to use telnet command. Telnet, then copy this IP address, paste. The port number is nothing but 5432. You see it is hanging. In Windows also telnet is available, but it might not be enabled by default. You just have to go to control panel, search for telnet, make sure you enable Telnet, and you should be able to use Telnet without any issues. Using Telnet, we can validate whether we are able to talk to the database or not. Here it is saying we are not able to. Now you have to use this command so that you can talk to the database. Here, I would suggest you to use your IP address rather than saying 0.0.0.0. If anyone else know the IP address, they should be able to connect to it and they can mess it up. For that reason, it is not advisable to use 0.0.0.0. Now, I also don't want to use 0.0.0.0 because this is going live and people can connect to my database and mess it up. For that purpose, I wanted to get my IPv4 address. Let me say my IPv4 address. You can Google around and you can go to the relevant pages and you should be able to get the IPv4 addresses. My IPv4 address is this one. So let me show you how I got my IPv4 address. So this is how you can get the IPv4 address. There's something called as what is my IP address. I just went to the google.com and searched for this, and I'm able to get the IPv4 address. So I will use that to whitelist rather than whitelisting for everyone. Whitelisting with a 0.0.0.0 with simple passwords which are exposed is a little bit risky. Hence, I am actually whitelisting only my IP address. So the gcloud SQL instances patch perf demo instance SNIP authorized networks equal to /32 no require SSL. You have to say yes. Now again, it is patching the Cloud SQL instance, which means it is white labeling my IP address to connect to it. Once this is done, again, we can use Telnet to confirm whether we are able to talk to the database or not. So if you end up using GCP and if you run into any issues to connect to the GCP database, feel free to reach out to us. We'll help you in overcoming the issue. I don't recommend you to use comments for that purpose. You can reach out to us using support@itversity.com, or even you can use comments. We can follow up with you. Only thing is, don't share any of the not public, private information in comments. You just say, I'm running into issue, can you help us? And we will have a live session also if required, and we will take it forward. Okay. Now, the next step is telnet. Now see, we are able to listen to 5432 port number on this. Now I can connect to the database without any issue. If you attempt to do this, it will not work because only this IP address is whitelisted. If I say 0.0.0.0/0, anyone can telnet and anyone can connect to the database without any issue. Now let me come out of it. Once we set up the database and once we set up the password and once we configure the network, the next step is to validate, which we have done already. Now it is time for us to connect to the database. I'll be using psql command to connect, or we can also use pgadmin. Let me use pgadmin here. So I'm opening pgadmin. Pgadmin is IDE, Integrated Development Environment. And here, let me say register server. Name is nothing but GCP. What is the name here? Perf demo instance. Perf demo instance. Connection. The IP address is nothing but this one. Port number is 5432. Maintenance database is fine. Username is fine. Password is this one. Perf demo 123. Now I should be able to click on save and you see it is connected. If you have pSQL setup, you can also use pSQL to connect. The way you can connect using pSQL is like this: pSQL --host equal to the IP address is nothing but this one. then port equal to 5432. Port is optional here because it is default port. Then username equal to Postgres. Then DB name equal to Postgres, which is super users database. Then it will prompt for the password. The password which I have given is nothing but perf demo123. And you can see I'm able to connect without any issues. So here, this is the CLI version, which is 17.2 PSQL version. The server is 15.10. Okay. Once this is done, now if you want, you can actually set certain database parameters. First, let's review these. Again, don't worry too much about these to understand. It will just give an idea about maximum number of connections, shared buffers, and work memory. These are more of a DBA related settings. We just wanted to review, and if you wanted to increase, we can increase. So here shared buffers is already more than 1 GB, hence I don't want it to change. But work memory, I just wanted to increase it to 16 megabytes. So you can also think about changing the configurations of the database from the perspective of performance tuning. But this session is more for SQL tuning, not the actual database level tuning. Hence, I'm not getting into explanations about this. For now, I'll just increase the work memory to 16 MB. The way we can do it is like this. We can say alter system set work underscore mem equal to 16 MB. Okay, it is saying permission denied to set parameter work mem. Here I have connected using Postgres only. For some reason, it is not letting me to do that. Probably I have to deal it in a bit different way. When I actually test it in my Docker related ones, it worked. Because this is Cloud SQL, probably there might be few restrictions when we attempt to do this remotely. For now, we can ignore it. It will not make much of a difference. Now, we might want to see the statistics about whatever we are doing. Reviewing the statistics come under monitoring. In case if you wanted to set up monitoring for your database, you can set up. The commands which you are supposed to run are nothing but these. Again, these are not related to actual performance tuning of SQL queries. This is like prepping our environment. Okay. So here total time does not exist. Let me say /d pg stat statements. We have total plan time and all. We have to update accordingly. In this case, I am interested in total execution time. So let me actually say select query calls, then total execution time comma rows from pg stat statements order by 3DESC. Now you can see the details here. Okay. As of now, we just set up the database. We haven't run anything. Hence, this doesn't make much of a sense. You can also take care of all these commands using pgadmin, which is a lot more friendly. So to get started, what you can do is you can right click on the database and then you have to get into this server and then you have to right click on the database. The database which you wanted to use is nothing but okay, we haven't created any other database. Cloud SQL admin you can ignore. We'll be creating the database and we can take it forward. To create the database also, we can use query tool. So I'm connecting to Postgres database and I should be able to use relevant commands to set up the database. The way you can set up the database is like this. I'll be creating a database by name performance tuning. Let me zoom in a little bit here. Okay, now let me see if I can collapse the sidebar. Okay, it's fine. Let me go ahead and run it. Let me run this. Now the database is created. We have to connect to that database. For that purpose, we can refresh this. And then we can right click once it is connected and then launch query tool. Now we are attached to the database performance tuning. This one we are attached to Postgres database. You can see here, this is the database name, this is the username, and this is the server name which we have given here. And this is the database name, performance tuning. The user which we are using currently is nothing but Postgres. If you wanted to use PSQL, as the database is created, we can also say /c for change, then performance tuning. Now we are connected to the performance tuning database. So either we can use pgadmin or we can use PSQL based on our preference. Most likely I'll be using pgadmin because it is a lot more intuitive compared to command line. Now let me exit from here. Let me take it to the next step. So as of now, we are able to set up the database without any issues. We have even validated by creating a database in it. In case if you wanted to create a table, you can create a table. Let me also create a table real quick. I'll be dropping again just to make sure everything is working as per the expectations. You can select, you can run. The table is created. To drop, you can say drop table sales. Now we should be able to run it and we are good to go. And also keep in mind, we can launch PSQL from here also. You see here, there is PSQL tool and you should be able to launch without any issues. And you can actually run the commands from here also. In case if you wanted to run using command line, you don't need to launch the terminal and take it forward. However, you need to ensure you specify the correct path to run the commands because here it will use some standard path which is relevant to pgadmin, not to the location which you are working on. So things can become a little bit tricky if you start using PSQL here. For now, let's close this, but I just wanted to highlight that you can use PSQL from the pgadmin as well. Now that's about the first item, which is nothing but setting up the Postgres database. As we are done with it, now it is time for us to go to understanding execution plans. Again, I'll open the Medium article and then I'll walk you through the details. Then we'll get into action. Okay, now let me go to relevant article. I'm just looking at the commands to set up. Yeah, actually it is in this setting up the database itself. Now, if you want to create additional tables for the performance tuning, the way you can do it is like this. You can launch using PSQL. Let me go back here. Now let me launch PSQL. First, let me go to the relevant folder. It is nothing but projects, internal, bootcamp. This is my location. Then data engineering courses. So once you clone the data engineering courses Git repository, you will see SQL performance tuning. You have to go there and then you have to go to setup. You should be able to see the create tables.sql and load data.sql. Using this, you should be able to set up. Okay. You can also use the complete path here. Let's say PWD, get the complete path. If you are using Git Bash on Windows, you should be able to use PWD like this. But if you are using PowerShell, you have to identify relevant command to get the complete path. In case if you wanted to use complete path, here I'll be using the relative path only. So that being said, now again I have to launch PSQL. Let me launch PSQL. Let me enter the password. Then let me switch to the database. The database name is nothing but performance tuning. Once that is done, let me see which location I am in. I'm in setup. Setup have the create tables.sql and load data.sql. Now I should be able to say /i, then 01 underscore create tables.sql. If you are in a SQL performance tuning folder rather than setup folder, then you have to say setup /01 underscore create tables.sql. Now let me run this. All the tables, indexes, and views are created. I also wanted to load the data. For that purpose, I have to say 02, then load data.sql. Now data is also populated. We also have the script to verify to see if the data is actually populated or not. You can see it have ran queries on some. Actually, it is running queries against all the tables. You can see here. Everything is working fine. So we are able to see the data in the tables. If you wanted to get the list of tables, you just have to say /d and you can see all the tables and other objects also that are actually set up as part of the setup process. So by the time you complete this first topic, let me go to the material. Where is the Git repository? Yeah, this is the one. By the time you complete the first topic, which is nothing but setup Postgres database.md, you should have all these tables set up so that you can continue with the next topic. Now let's go to the next topic, which is nothing but understanding the execution plans. Already I have opened the Medium article. Let me go through it and then we will take it forward. So here, one of the important tool, we can call it as tool, to tune the performance is execution plans or explain plans. First, you should be able to review the explain plan or execution plan. It will give a lot of insights about your query execution, and then you have to take it forward. Most of the MHUs, when it comes to performance tuning, they consider execution time as the key criteria to evaluate the performance. But keep in mind, it's not about execution time. There might be a query which might be taking 2 seconds, but it might be using only 1% of the overall capacity. And there might be another query which might be taking only 1 second, but it might be taking away 50% of the overall database capacity. Which one is efficient? The one which is taking 2 seconds with 1% of database capacity, or 1 second with 50% of the database capacity? Obviously, the one with 2 seconds taking 1% database capacity is better compared to the other one, right? So don't get carried away with the execution time. Explain plans or execution plans will actually give you the details about what are the resources that are being used to execute a query. There is a very simple metric called as cost. Focusing on the cost, you should be able to determine whether the query which is returning results in a specific time is efficient or not. I'll not be spending too much of details about interpreting explain plans or execution plans because it will take a lot of time and it is not practical to cover in this workshop. Hence, I'll directly get into some important aspects which you can review to evaluate the explain plans or execution plans and come to a conclusion whether queries are running effectively or not. Now, first let's understand what is an execution plan or explain plan. Execution plan or explain plan is also known as query plan. It shows how the database engine execute your SQL query. When you run a SQL query, it will be compiled into low-level code. And then using that low-level code, it will actually go to the tables, get the data, and then take care of the overall execution. And you should be able to see the execution plans or explain plans or query plans in any database. It is a standard concept. It is not specific to Postgres. Even in data warehouse type database also, you should be able to review explain plans. Databricks provide the details using the same command called as explain. Same is the case with Redshift and all. There are few databases like BigQuery where explain command might not work, but still it provides details in a different way. That being said, in case if you are using SQL Server, you should be able to use set show plan text and then set statistics profile, and you should be able to see. When it comes to MySQL or Oracle or Postgres, the commands are explain, explain or explain analyze, explain plan respectively. You can also use something called as dbms_explain.display for Oracle. Now, why execution plans matter? It will quickly identify the bottlenecks. It will spot missing or ineffective indexes. How to determine that? You will see quite a few scenarios or problem statements where you will be able to spot certain information that is missing. We'll be talking about execution plans quite a few times in this course, not only with respect to this topic. Then it will also give you the estimate versus actual. It might not be relevant for all the databases. In many cases, it will be. And also, if you wanted to get into join level details, it will also tell how the joins are being performed. Is it using nested loop or hash join or merge join? So these are the things which will give you, these are the details which will be provided by the execution plans or explain plans to you. That being said, how to generate and interpret explain plans depending upon your database, you can take it forward. When it comes to PostgreSQL, one of the common approach is to use explain analyze. Now, let me go back here. Let's run a simple query with explain analyze, and then we'll take it forward. I'll be using the PG admin than command line so that it is a little bit more intuitive when it comes to exploring these things. Before running any query, let me expand the schemas here, and then let me review the tables. You can see whatever tables that are created by running the scripts are visible here. Now, just to test, let me make sure I'm in the right database. Performance tuning, this is the one which I wanted to be. I'm in the right database. Just to make sure any mishaps, let me close this Postgres related one. Now let me say explain, analyze, select count of star from order items. I'm just running this and you can see the details. It is doing full table scan because it is saying sequence scan. We will see why it is doing full table scan and all at a later point in time. And you can also see the cost. Typically for select count of star, if there is an index, it is supposed to use the index, but in this case, it is not using index, even though there are indexes. The reason is we are supposed to compute the statistics also. Once we compute the statistics, most likely it will end up using index scan rather than sequence scan. Let's run one more query just to understand how the explain plans will be. In this case, let me first say select star from orders. You can see the data here. We have order ID which is indexed. Now let me say explain, analyze, select star from orders where order underscore ID equal to 3. Let's make sure we select it and click on execute script. Now you see it have done index scan. It haven't done sequence scan. If it is doing sequence scan, that means it is going to the entire table and then it is filtering for this one record. Because the order ID is the primary key, it is indexed and it is able to get the data directly using the index. Index scan will narrow down the search and the cost will be much low compared to sequence scan. You can see here the cost is 0.29 only. Now let's pick one more scenario just to understand how it will look like when it comes to full scans rather than count. This is more appropriate. Now let me say explain analyze search star from orders where in this case let's say status equal to pending. First let me see if status is indexed. Status is not indexed. Even status is not appropriate. Let me pick customer ID. Okay, customer ID equal to 890. Why I have chosen customer ID, not status? Because status is a dense column. It have few unique values. It is not supposed to be indexed. That's why I'm not using status. I'm using customer ID because it is sparse column. Sparse column means it have quite a lot of unique values. Now let's run this. However, in this case, the customer ID is not indexed, and you can see it have done. Okay, it is indexed actually. IDX orders customer. Okay, my bad. I am looking at a wrong table. Now let me actually look at orders. Let me check the columns. We have order ID, customer ID, order date, ship date, so and so forth. Let me pick the total amount or something which is sparse column, which is not having index. Let me pick the order date. This is a better candidate. Okay, let me say order date equal to. Now let me explain. Now you see, oh, still it is okay. I have to check the indexes. Let me check the indexes here. There are quite a lot of indexes on this. So order date is indexed, status is indexed, customer is indexed. Let me review the data once again. Let me pick the ship date. Now you see it is doing sequence scan. The cost is saying 0.002 to 234.00. Okay. However, when it comes to this one, almost similar query, the cost is 0.29 to 8.3. So the cost is significant for this. It is almost 30 times slower because this is 8.3, this is 234, which is close to 28 to 29 times, right? So this is how you should be able to look at these statistics and confirm the efficiency of the query. Don't just focus on the execution time. And if you look at the execution time, this is 1.396 milliseconds. Let's also check this. Even execution time is faster here. Okay, but what I'm trying to say is don't just get carried away with the execution time. You have to focus on efficient usage of resources on your database. That being said, now let's continue here. Common red flags which you see as part of explain plans are nothing but full table scans on large tables. Here we have already seen an example. This is actually doing full table scan. Also, there's a concept of SARGable filters. I haven't covered it yet, hence I am not getting into too many details. And here, you also need to make sure that the statistics are up to date. If the statistics are out of date, also you will be seeing inefficient queries. What are the statistics? There are queries for that. You can actually run some queries to get the statistics details, and it will give you an idea whether the statistics are up to date or not. You can search for it and you can take it forward. And when the joins are performed, we will see quite a few other examples also. I just get started with explain plans, but again, as we get into the other scenarios, we'll be seeing quite a few queries, and I'll talk about these nested loops and all as well up to an extent, but not into too many details. One of the thing which you need to keep in mind is nested loops on large joins is not efficient. If you have two big tables and if you are performing join, probably hash join or merge join is more efficient. Then no index usage. Sometimes even though index is there, it will not be using the index. Again, SARGable is the one of the scenario. When we get into SARGable queries, you will understand what I'm talking about here. So that being said, now let's get into the details about scenario one, where we'll not be seeing the index usage. So here I'm picking this simple query and I'm running and this and go to indexes. So there is no index on segment, and segment is a dense column. It have only few values. Let me first preview the data, select star from customers. You can see outcome here. And you can see the segment. There are only few unique values: consumer, enterprise, small business, etc. Okay, and it is not indexed. Hence, it will actually provide you the full table scan or sequence scan. Sequence scan in Postgres is same as full table scan in other databases like Oracle. Then this is the example where you will see the index usage. And if you look at the query, it have a join orders. These two are joined. And if you look at the orders, we have an index on order date. We have order date column here in the condition. And also we have a index on customer ID in orders. So this field from orders is also indexed. You can see here. You can go to the details if you want by looking at the properties. So you can see the columns. You can see customer ID is the column which is indexed with this index. Now, even though this is a join query, because order date and customer ID in orders are indexed, you can see it is only doing index scan. This is how you should be able to go to the details if there are any missing indexes when it comes to the queries. If the index doesn't exist, it might end up doing full table scan, and you might have to add the index and you can take it forward. So this is how you should be able to review the execution plans. Now the next topic is, let me go to the Git, because I'm using that as reference when it comes to walking through the agenda. Where is Git? It's in the other screen, sorry. So the next one is indexing foreign key fields. So this is the topic which we are going to talk about. Now let me open that and then I'll take it forward. That being said, before going forward, I wanted to see if there are any questions. And you guys can ask questions any point in time and I'll answer. Okay, there is one question saying, what is the reason to add uh, 32 after IP? Is it bit size? Yeah, don't worry too much about that, Aditya. You can actually explore that. I don't want to dilute by getting into those complex networking concepts here. So for now, just blindly follow by adding 32, it should work. Okay, the objective should be you connecting to the database and making sure you can talk to database. As long as that objective is served, we are good to go. That being said, let me also refresh once. Sometimes the YouTube comments will not be refreshed. Yeah, I'm up to date. Before going to the next one, in case if you like the content, make sure you click on the like button. If you have any feedback, make sure to share the feedback and then you can take it forward. Now let me go to the next one here, which is nothing but to indexing foreign key fields. Okay, so this is the one which we are going to talk about. Now, why index foreign key fields? The main thing is faster join operations. It will also improve concurrency and reduce locking. When we perform inserts, updates, and all, if the foreign key fields are indexed and if the joins are relevant when it comes to updates or inserts, and also sometimes when you update certain values in the parent table or in the child table, you might have to look up into the other table. So in those scenarios, it will improve the concurrency and reduce the locking. And also query performance consistency over time. As data grows, a missing index on a foreign key column can lead to increasingly slow queries. So for example, the table is empty. And if you are running queries, or table have only 10 records, and if you are running queries, it might not perform poorly whether you have index or not. But if the table have 10,000 records, it will start degrading the overall performance. It will exponentially slow down the performance of the query. Now, if the business grew and if the table have, let's say, 100,000 records or millions of records, missing index can significantly slow down the performance. If 5, 6 users concurrently try to access the database, that database might end up crashing. It can be that problematic. Okay, so this is a very important statement which you need to understand. Over time, as data grows, a missing index on a foreign key column can lead to increasingly slow queries. Amazon.com, right? You might be placing orders on Amazon.com or Flipkart.com. And when you log in and when you go to your orders, it will list all the orders. So how it will list all the orders at a very fast pace? If you think about it, when you log in, you have an account. For your account, there will be an ID, right? And most likely that ID will be in customers or users table. Okay, users or customers tables will not have the order details. Now, there might be extra table called as orders, same way as the tables which we have seen here. Let me go here. And there might be a table like orders, and orders will have the customer ID, right? Now, going to orders, Amazon.com or Flipkart.com has to pick the orders, and it might also have to go, it might have to go to even products to get the product details. So there has to be join between customers, orders, order items, and products. Now, if the foreign key columns that are used in this whole chain are not indexed, then if 10 different users try to get their orders, Amazon.com can come to it. They might lose, are typically used for logging purposes, will not be using for reporting purposes and all. In those scenarios, foreign key fields need not be indexed. That's why by default, foreign key fields are not indexed in most of the relational databases. But primary key fields are always indexed. Okay. Now let's get into the details so that you understand what I'm talking about here. Let me see if any important material needs to be covered, then I'll take it forward. Yeah, example use case. First, let's make sure we drop the index, and then we'll see the explain plan or execution plan, and then we'll take it forward. Okay. Now I'm copying and pasting. Let me run this. IDX orders customer. Okay. My bad. The syntax is not correct. I think I haven't validated this command. We should not be having the other details. As earlier it have failed, it is saying current transaction is aborted. So what I have to do is, I just have to say rollback or commit. If you see this error, just do rollback or commit and then run again. Now the index is dropped. Now let me run this query, explain, analyze. So here I'm only searching for customer ID 1. And you can see when it comes to orders, it is doing sequence scan. Overall cost is 0.282 to 242.38. Out of that, the majority of the cost is to get the data from orders, which is 234. So 234 plus this one is adding up to 242.38. Now let's create the index. So you don't need to do any additional testing and all. By just reviewing the explain plan, if you are able to identify the missing indexes on foreign key fields or SARGable fields, if you add indexes, the performance can go up. However, you should not be over-indexing. I'll also talk about the limitations of over-indexing and how to decide to avoid over-indexing in a separate topic very soon. You will understand at that time. For now, let's run this and see what happens after the index is created. From 242, it came down to 41.09. You can see here, right? Earlier it is 242, it came down to 41.09. And the cost of bitmap heap scan on orders using customer ID equal to 1, it came down to 32.71. So from 238 odd, it came down to 32.7. There's almost 8 times improvement in the efficiency of running this query. So that is what about indexing foreign key fields means. Now, there are certain best practices which you can consider when it comes to indexing foreign key fields. The first one is always index the referencing column. Then balance read versus write costs. Each new index slightly slows down insert, update, and delete operations. That's the additional overhead whenever you index. Okay. Once again, I'll reiterate, the first best practice is always index the referencing column. Okay, which means you have to consider the child table foreign key column, and you can consider indexing it in case if the joins are very common. However, the more indexes you have, the write operations such as insert, update, and delete will be slow. You need to make sure you understand the effect of it, and you have to make wise decisions. But when it comes to foreign keys, they're typically among the most frequently queried relationships. There are exceptions, but in general, especially for uh, point of sale system, banking transactions. We frequently query based on the foreign keys. Hence, indexing is better. The read performance gains often outweigh the write overhead, because we will not be writing that often when it comes to our orders. But reading is very common. Okay. And when it comes to best practices about deciding whether you have to create index is actually used. After creating the index also, you have to check whether it is being used or not. And also watch for non-sargable queries that might prevent index usage. I'll be talking about non-sargable queries very soon. Then check for potential locking. Missing FK index can cause table scans during referential integrity validation, and it can slow down the overall performance because of the locking. That's where this point is important. When you index, improved concurrency and reduced locking is another benefit, even when it comes to write operations. Give appropriate names for the indexes. Don't give very generic names. Just use probably IDX to begin with, then the table name, and then the column name which you are indexing. That will make sure you understand what this index is for as soon as you see the index itself. Okay. Now, common pitfalls. What are the common mistakes which we do as amateurs or even experienced professionals? Sometimes they overlook. Some of the things which they overlook is they feel that assume parent key index is enough, or indexing a parent key column is enough. They might not keep in mind about indexing foreign key column. And I have seen this issue time and again in my 20 years experience, uh, uh, be it my first job as a fresher all the way till recent times. I have seen quite a lot of issues around not indexing the foreign key column. And another common pitfall is over indexing. If there are 10 different patterns users are using to query, they end up indexing 10 different columns. And as I have mentioned to you earlier, too many indexes can hurt write performance, so you have to be very careful. One of the ways I have mitigated this issue, where users have 10 different queries to run, is by negotiating with the user. What are the common things which they want to filter, and have a user experience in such a way where they go in hierarchy. For example, let's say someone wanted to see if a particular car is being sold or not on a given day or not, right? So instead of directly searching for the uh, status and other fields, I'll ensure first the user is searching for a particular store or dealership where the cars are being sold, and in that a particular model, and then in that pending, rather than going the other way around. So if the user end up looking for pending is a dense field, so it will give lot of data. And then if he start applying filters in reverse manner, the performance will be very slow. Rather, if we force the user to select multiple filter criteria in specific order, like from a high level to lower level, then it will be much better. And sometimes we have to enforce until certain conditions are met, we will not be hitting the database at all. Okay, so that is how we can negotiate with the business users and make sure we avoid indexes for all patterns. First, we have to restrict the patterns which are supposed to be used by the users, then we can take it forward. Okay, and then another common pitfall is ignoring SARGability. I'll be talking about SARGability very soon. You will understand what I'm talking about here. So this is about indexing foreign key fields. The benefits include speedier lookups, reduced locking, more consistent performance as data grows. This is a very important point. When it comes to creating these indexes, always weigh the impact, consider DML operations write overhead, balance against read performance gains. In most real world scenarios, indexing foreign keys remains a best practice. Okay. So what is the takeaway? Properly indexed foreign keys ensure that referential integrity checks and join operations run smoothly, preventing bottlenecks in high concurrency applications and large datasets. This scenario exemplifies a universal SQL optimization principle across all major database platforms. That being said, now let's get into the next next topic. I think it will take a lot more than 2 hours. So what I will do is after additional two scenarios, we'll wrap up for today, and then we'll continue over the next weekend, and I'll take care of the rest of the scenarios. I thought I'll be able to wrap up in 2 hours, but I don't think it is possible. I might have to rush through if I have to, and it might not give enough value to you. For that reason, I will split this into two sessions. Okay. Now there are few questions. Let me take those questions and then I'll take it forward. Let me actually share my screen where the questions are, and then I'll walk through the details. Let me zoom in here. So Thanos, for any aggregate function, is there any optimization technique? So this has to be elaborated a little bit. The question is too generic, Thanos. If you can post your question in comments, probably next week I'll talk about that. Okay. Now Aditya have asked a question. While adding indexing, should we take how often the data is being added to the table? Typically, we are talking about transactional systems. The data will be coming in into the database in real time. And yeah, they have mentioned to you for foreign key columns, it is a common practice to create indexes if they are missing. And there's a follow-up statement also. Let me also read through that. I mean, is there a measure to understand how many indexes should be enabled on a table based on the how frequent the data is being added? I think I have already answered that question. So one of the common practices I follow is on the dense columns, I typically don't index. Like if I go here, right, and if I look at customers, so segment is a dense column. I don't index on segment. And postal code, probably I might index. If I want to index city, probably I create a composite index based on country and city, if at all I wanted to. So like that, based on the search patterns, I will determine how least number of indexes can solve all the requirements of the business users. Many times I will negotiate with the business user saying, okay, this is not appropriate to actually randomly search anything. You have to follow certain pattern for better user experience, which is a lot more intuitive and all. And we will enforce that in the application itself. In the application itself, rather than showing all the filters in one shot, first we'll ensure that, okay, you start with this filtering, and then there will be sub filters within that. And as people navigate and choose them, then only we will hit the database and we'll get the query results. So by enforcing certain user experience patterns, we can come up with a lesser number of indexes to solve the problems of the business users in a more constructive manner. Okay. So once again, I'm reiterating, I'll try to avoid indexing dense columns directly, especially on single column. And sometimes I'll use composite indexes based on certain requirements. And another common practice is to negotiate with the business users where the user experience is a lot more intuitive and avoid these common pitfalls, which will result in too many indexes. Okay. I hope I answer your question, Aditya. If you have any follow-up question, feel free to ask. Now let me go to the next item. The next item is nothing but indexing based on search patterns. Probably after joins versus subqueries, we will wrap up for today, and then advanced techniques like partitioning, optimizing ranking queries and all, I'll cover in the next week's session. Okay. Now this is also very important topic. Let me open my Medium article. Yeah. So in this, we'll be using Toyota sales data. So first we have to create the tables. There'll be two tables. One is Toyota sales reps. Second one is Toyota sales. And we'll be using these datasets in other topics as well. To create the tables, you can directly copy these and go to SQL or pgadmin. SQL developer is Oracle IDE. Because I'm more Oracle user, I tend to use SQL developer. Sometimes I might get carried away with SQL developer itself. Whenever I quote SQL developer in this session, make sure I mean pgadmin, because here we are talking about Postgres, right? So what I'll do is, as this is completely a new dataset, I'll create a new query editor, query tool. It is also connecting to database using performance tuning. Postgres as user, the database is performance tuning. In the same performance tuning database, I am first creating the table by name Toyota sales reps. Then I'll be creating Toyota sales, which is child table to sales reps. First, let me run this to make sure table is created. Now the table is created. Sales reps have these fields: rep ID, first name, last name, email, phone number, blah, blah, blah. Toyota sales have sale ID, rep ID, date, car model, sale amount, commission percentage, and sales status. Now let me run this command to add foreign key, and the foreign key is between Toyota sales sale rep ID to Toyota sales reps rep ID. This is primary key in this. This is foreign key to Toyota sales reps from Toyota sales table. Now the constraints are created. Let's go to the next item here. Then we have to load the data. You already have these commands which you can leverage. Again, you have to be in setup folder. The paths are changed. I will update the instructions also as we carry forward. And keep in mind, you have to use backward slash in the beginning like this, because the files are in your local system and GCP database, Cloud Postgres database is in GCP. When you wanted to use copy command to copy data from your local files into remote Postgres database, you have to use backward slash at the beginning. And it might fail with some permissions. We'll take care of those permissions also. Okay. Now, again, I'm coming out here. Let me make sure I'm in the right folder. I'm in SQL Performance Tuning. The path of the data is data, then Toyota sales. Within Toyota sales, we have two folders. One is sales. Second one is sales reps. When we have two different tables where there is a relationship, first we have to populate the parent table followed by child table, unless the foreign key. Now let me launch PSQL from here. Let me enter the password. Let me say /c performance tuning. Now let me use this command as reference. So copy Toyota sales reps, which is the table name. Okay. Let's make sure the table name is correct. Toyota sales reps is the table name. After that, we have to say from, then the folder, which is nothing but data, Toyota, sales, then sales reps, then file name. What is the file name? Sales reps data.csv. After specifying these, you have to specify the format with clause along with header true, because the files have the header. Okay, I hit enter. How come it is complaining the table doesn't exist? Let me make sure I commit. Probably I might have to commit. In databases like Oracle, DDL statements are auto commit, but in Postgres, I think it is not auto commit. That's why it have failed. Now let me copy this. Let me paste. Okay, I have to specify the other details also. So the syntax says with format CSV header true. Let me minimize it here so that the complete command is visible. Now you see data is populated without any issues. So this is the command used. And if I run it again, it might fail because it might violate the primary key constraint, right? Like that, we have to copy the data for other files also. Let me copy here, paste here. Then let me make sure I update this one also. So data Toyota sales. Then sales, then Toyota October 2024 sales data.csv. Let me run this. Now you see 5,000 records are populated. I have to use the same strategy for the other two also. So I have fixed the instructions also, but when it comes to Git repository, I might have to fix after today's session. I'll do that. Okay, so all the commands have ran successfully. Let's say commit. Yeah, here it is auto commit. In PSQL, it is auto commit. In pgadmin, at the session level, it is not auto commit. So you can ignore this. You don't need to worry too much about it. As the data is populated, now let's validate to see if we can read the data from the tables using pgadmin or not. So we have to say select count of stars from Toyota sales reps. We should have 22 records. You can see 22. And when it comes to Toyota sales, we should see 15,000 records. So data is available as per the expectations. It is also better to just quickly preview the data to ensure the data is as per the expectations. Otherwise, sometimes what will happen is if there is a bug in our copy command, it will only have null values in all the rows. That is one of the common problem which I have seen. You just need to make sure as soon as data is populated, it is validated by running commands like this. So the data is as per the expectations here. Now let's get into SARGability, right? First, we need to understand what is SARGability. SARGability means such argumentable. So here you need to ensure the indexes efficiently. When it comes to index scans, there's a concept of index full scan and index range scan and index unique scan. There are three types of index scans. One is index unique scan. Second one is index range scan. Then the third one is index full scan. What it actually mean, right? So first, let me do some whiteboarding here so that it is clear for you. I am using there should be a table. Where is the table? Otherwise, what I will do is, yeah, this is not appropriate. I will use this approach. So I'll just take the screenshot of this. Okay, if you look at this here, the sale IDs are sorted in ascending order, but in actual table, the sale IDs might not be in sorting order like this. It can be scattered. Table, there's no preservation of the order. It will just populate the data into the table wherever there is enough space. That's where the indexes comes into play. So index is another table structure. Let me see. There should be a way to create a table. Okay, now let's assume that there is an index on More actions. Let me delete one of the columns. There should be a way to delete a column. It should be automatic. Why it is not showing? This is the one. So I just want two columns and let's say 10 rows. Okay. And let's say the index is for sale ID. Okay. If the index is for sale ID, if the index is for sale ID, the data will be sorted in sale ID. Irrespective of the order, the data is populated into the table. Even if the first record is 10, and if the second record sale ID is 1, the third record sale ID is 13, the fourth record sale ID is 3. In table, it can go in any order, but in index, always the data will be in ascending order by sale ID. Okay, so the way it will be is, let's take the example of sale rep ID rather than sale ID. That way it will be easier, right? Now you have 1969, so and so forth, right? Now let's say this is one. The record with 6 is inserted. It will update the index like this: 6, then R3, because it is in row 3, and then 9, something like this, R5. Then comes 10. 10 is now, it has to go after 9. So the index will be corrected accordingly. So there will be, this will be moved. It will not be moved literally. Somehow it will maintain the order. When we rebuild, it will move, but in between also it will maintain the order somehow. Okay, I don't want to get into all those internal details here. Also will be populated, and now the fifth record in the index will be 10. Now 4 or 7. So the data is in ascending order when it comes to sale rep ID. Now, if we try to access for sale rep ID 1, it will do index unique scan, because there will be only one record. As soon as it get that record, you are done. So when it comes to sale ID, when we perform any operations where we say sale ID equal to 2, sale ID equal to 3, sale ID equal to 4, it will perform something called as index unique scan. As soon as it get the record, it is done. Now sale rep ID have the duplicates. For example, there are 2 9s. So when you say select star from or select count of star from sales where sale rep ID equal to 9, it cannot just do index unique scan. It has to do index range scan. Until it identify the next value, which is not 9, it has to perform the range scan. That is what range scan means. Okay. As soon as it move beyond 9, it will stop going to the index for the row identifier and get the data from the table. And keep in mind, if you say select sale rep ID from sales, it will only do index scan. It will not even go to the table. But if you say select star from sales where sale rep ID equal to 9, by going to the index, it will identify R2 and R4 are the records which contain the data related to 9. And it will go to the table and it will get those 2 records. So this will be retrieved and this will also be retrieved. Okay. That is what is index range scan means. Now, there might be a scenario where you say select star from sale rep ID, where sale rep ID is greater than or equal to 0 and less than or equal to, or greater than 0 and less than or equal to 100 million, which covers the entire range. So even though it is indexed, it might have to do the full table, full index scan. So when it comes to indexes, you have 3 types of scans: unique scan, range scan, and full index scan. That's where SARGability comes into play. Now let me go back to the material here. And if you look at it, this is the very important statement which you need to understand. When a query is SARGable, the database optimizer can perform an index seek rather than a full table scan, or index range scan or a index full scan, depending upon the database you are using. Again, database to database, there might be some subtle differences. In Oracle, you can clearly see index unique scan, index range scan, index full scan, and you can clearly understand, but in other databases, the terminology might be a little bit different. Now, how you need to evaluate the performance, right? That's where making sure writing SARGable queries is very important. Now, let's create a index on sales status. Even though it is a dense column, I'm creating an index on sales status just for the demo. Okay. Let me see if the index already there. So which one we are talking about? Toyota sales, right? So let's go to tables. Let's refresh. You can see Toyota sales. Let's review the indexes. Okay, there are no indexes apart from primary key fields. Did I define the primary keys? Let me check that. I might not even have the primary keys. Yeah, I have primary keys. It is not showing the primary key details here, even though there are primary keys. I think only the additional indexes will be shown. Even here, it is not showing the indexes. That's fine. Let me expand the columns, and you can see all the columns here. And you can see the details. Sale ID is primary key. So primary keys are always indexed, even though they are not shown here. Probably under constraints, you might end up seeing. Yeah. So that being said, now we are talking about SARGability. And for that, first we wanted to create an index, right? So the index is on sale status. Let me run it. Now let's run this query to see whether it will use index or not. First, I am using this. Okay. Now, if you look at this, we have a function on sales status, lower of sales status, and we are saying equal to pending. Now, if you think from the database perspective, I think lowercase have the higher value in ASCII. Hence, the data will be typically sorted or typically stored like this. Let me open the browser here. Right. Let's say you have cancelled pending. What are the other values we have? Select distinct sale underscore status from Toyota sales. So there are only three values: completed, cancelled, and pending, right? Now, let me insert a table. Okay. Now let's say you have cancelled, pending, and completed, I guess. Yeah. So the way data will be is like this. So first you will have cancelled, then completed, then pending, then cancelled, all in lowercase, then completed, then pending. Now, if you have data like this, if you say lower equal to pending, or if you say status in pending comma pending, or greater than pending less than nothing but column. Now, if you think about it, if you say lower of pending, lower of column value equal to pending, it has to go through the most likely the entire index. It has to do index full scan because after pending with P capital, there are quite a few other values which are starting with other characters in lowercase. And only after going through all the data, it will be able to get the pending here. So either it will be inefficient index range scan where it has to scan more values, or it can be index full scan. Most likely when you use functions on the left side, it will end up using index full scans, not index range scans. Okay. Now that being said, let's run this. And it is actually doing a full table scan, even though the column is indexed. Now, instead of doing this, let's make importance of standardizing the data. When it comes to data in the database, either we'll be storing in uppercase or lowercase or capitalized like this. And then we will be able to come up with queries like this, avoiding the functions on the columns. Now you see, it have performed the index scan, not the full table scan. Okay. We avoid functions on the left side columns. It would have done index range scan instead of index full scan. But in Postgres, it is full table scan versus index scan when you make the queries SARGable. So these are SARGable queries. These are non-SARGable queries. Okay. Some of the databases support function-based indexes. So you can create an index based on the function. When you have the function-based indexes, the query is SARGable, but not all databases of standardizing the data. They don't standardize the data. By not having standardized data, you will end up degrading the performance by coming up with queries like this. It is better for us to understand the importance of standardizing the data and then use relevant queries to serve our applications. Okay. Another SARGable scenario is using like. Okay. Now again, if you say percentage Corolla percentage, it will do the full table scan or full index scan. However, if you say Corolla percentage like this, then it will only do limited range scan instead of doing full index scan. Okay. So this will result in full index scan because there might be other characters before C. Let's take the example of this one, percentage OROLLA percentage, and it will look for all combinations and it will see if there is any string with the Corolla in the middle, which is not appropriate. This is much better. This is SARGable. And how we deal with in our applications? In our applications, when we provide the feature of searching based on a last name or email ID, we'll ensure the user enter at least 3-4 characters at the beginning. And then we will show the results. That way, the range will be limited and the queries will be faster. Sometimes you have to negotiate the terms with the business to make the interface a lot more intuitive and also a lot more performant. Just tweaking the queries behind the scenes might not be enough. Okay, so in these scenarios, I typically end up fighting with the business and changing the user experience so that the applications can perform better. Okay, so that is about SARGable queries. And what are the key principles for SARGable queries? Avoid functions on indexed columns. Pattern matching should be appropriate. Avoid leading wildcards when possible, like this. So this should be avoided. And this is how it should be to make it SARGable. Okay. And also, if you are using date and time, you have to use proper date comparisons. Again, avoiding functions on the columns. That's how it will be. And what is the performance impact? If you use non-SARGable queries, it forces full table or index scans. It performs, the performance will be degraded with the data growth, higher CPU and IO usage, which means your application will be inferior. Your application cannot scale up. SARGable queries make sure they utilize index seeks rather than full table scans, or even within index in databases like Oracle, they utilize range scans over full scans. SARGable queries are better when it comes to scalability, and also they reduce the resource usage, overall IO and CPU usage. So here are the best practices which you need to keep in mind. You have to design your indexes based on common search patterns. Consider column order also in composite indexes. I haven't spoken about composite indexes that much, but composite indexes is also a very good strategy when it comes to tuning the performance of your queries, which will indeed tune the performance of your database, of your applications. And when it comes to best practices, you also need to make sure indexed columns free of transformations, which means you should not be using functions on the indexed columns. Also, you might have to rewrite queries to maintain SARGability. Sometimes you might also you might also have to negotiate with the business users to ensure the applications are searchable. Okay, so we will say, okay, user, when you search for it, you at least enter 3-4 characters and search. And they might use lowercase or they might use uppercase. If our data is in uppercase in the column, then irrespective of the case they enter, we apply the upper on the right side, which is literal, right? The constant value. Now, the data that is being passed on to search in our application is matching your data in the database. Even though the user entered something like this, let's say the user entered pending. Database is pending like this. Now, how you will be writing the query? You will say uh, sale underscore status equal to upper of, if your sales status is in uppercase, right? Upper of whatever he passed. You can either do it at database level or you can even do it at application level. In the application itself, before invoking the query, you can use your programming language functions to convert it to uppercase and pass it on to the database. That's how you typically take care of improving the performance of your applications. Okay, so by the time the data come to the database, it has to be aligned with the where data is stored in the database. That is one of the important aspects which you need to keep in mind. Also, monitoring is important. You have to use the execution plans to verify index usage. You also need to watch for implicit conversions. If you are a Java developer or a Python developer, most of the applications are built using ORM. Python developers use SQL Alchemy. Java developers use Hibernate or JPA, right? All these ORM-based libraries facilitate you to log the database queries. So you can pick these database queries, review the explain plans and execution plans, and see if the indexes are used properly or not, and then you have to take it further. That is how you can tweak the performance of your applications, by tweaking the performance of the queries in the database. Database level query tuning is very, very important for the overall scalability of the application. That being said, let's see if anyone have any questions around SARGability. Then we'll take up one more item and then we'll wrap up for the day, and we'll resume probably next week on the remaining topics. So let me refresh and see if there are any questions. Okay, as of now, there are no questions. Now let me go back to the next topic. That being said, once again, I'm reiterating, if you like the content of the video, don't forget to click on the like button and also share the feedback in the comment section. Also, make sure you go through the content once again and practice by yourself by setting up the environment. Probably you can try this weekend and you can shut down the database. In between, if you run into any issues, feel free to reach out to us. We will make sure your issues are sorted out. Okay. So the next topic is I have to go to my Git material first. And probably by next week, everything will be in place. I'll take care of everything to be in place. The next topic is over indexing and maintenance. So let me go back to my material here. We are talking about over indexing and maintenance. It's a small topic, hence we should be able to wrap it up fairly quickly. Already I have spoken quite a few things with respect to over indexing in the past, but I want to reiterate, and there are quite a few other things also which you need to make sure you keep in mind when it comes to maintenance of the indexing. I haven't covered maintenance of the indexing earlier. So what is over indexing? Over indexing occurs when a table has excessive indexing or indexes, typically due to adding new indexes for each query requirement without reviewing existing ones. It is called as premature indexing. If you are premature when it comes to coming up with the indexes on the table, you will end up with over indexing. Also, there might be a scenario where you might end up creating redundant or overlapping indexes. There might be a scenario where you might end up having obsolete indexes, which means there might be indexes in the table, but the application might not be using those indexes at all. So these are all scenarios when it comes to over indexing. And what is the impact of over indexing? The main impact will be the write operations, insert, update, or delete. These will become slow because for each and every index, you have a uh, separate object, the way I have shown earlier, right? So this is the table. I don't know why I am not able to extend. Oh man, this is very sensitive. Ah, got it. Yeah, actually, I can also drag these things. Yeah. So if you look at this, right? So we have an index on sale status. We have an index on sale rep ID. Let's assume, and also we have an index on sale ID. So for each of these indexed fields, there will be separate objects like this. And on top of writing data into the table, it also need to write data into all these indexes. So the more indexes you have, there will be more overhead when it comes to writes. So indexes typically improve the performance of reads at the cost of writes. Okay. So that is the main impact when it comes to over indexing, write performance degradation. Then comes resource consumption. So as I have shown earlier, if you have three indexed columns on top of table data, you also need to store index data physically, which means there is increased storage requirements. And also it will use additional memory to maintain the indexes. And also typically databases are backed up at regular intervals so that if something goes wrong, we can recover from the backup. And as more and more indexes are added, your backups might take a little bit more time. Then comes maintenance overhead. So typically when it comes to indexes, we rebuild indexes regularly so that the statistics indexes are rebuilt not for statistics. Over a period of time, when you perform operations on tables, when indexes are there, indexes can have a lot of overhead to serve your queries as fast as possible. I don't want to get into too many details, but you need to keep in mind, and indexes are easily accessible compared to non-rebuilt indexes. Okay. Now, if you have more indexes, the rebuild operation takes more time. That's what it is trying to say. So there will be longer index rebuild or reorganize operations. Also, to actually generate those explain plans, when we run queries, right, using explain analyze, it is generating explain plans. And the explain plans also have the cost. The cost is because of the statistics related to the table, like number of records in the table, number of unique values in the column. All these statistics have to be up to date. Okay. And we have to analyze the tables quite regularly to make sure these statistics are up to date. And if you have too many indexes, uh, it will take more time to update the statistics periodically. Okay, which means the system availability during maintenance windows will be reduced. Okay, so these are the other side effects when it comes to over indexing. Also, query optimizer issues. So sometimes the query will get confused. Means the optimizer at any level, they should focus on talking about writing performance degradation and resource consumption. If you are smart enough, you can also talk about this. These are more administrative tasks, not necessarily taken care by developers. Okay. Now, how to identify over indexing? So most of the databases will give details. When it comes to Postgres, you should be able to use this information schema view or table, which will give the details about over indexing scenarios. Okay. And what are the common signs? there will be unused indexes, there will be duplicate or overlapping indexes, high write latency, excessive storage usage. These are the common signs when it comes to over-indexing. Now, we spoke about over-indexing. Now, index maintenance. So I spoke about statistics, right? So you need to make sure that statistics are up to date when it comes to any table. You can run this command. So you can say analyze will compute the statistics. So analyze Toyota sales. It will make sure the statistics are computed. Like that, for each and every table and each and every index, we need to analyze to make sure the statistics are up to date. As I have mentioned to you earlier, over a period of time, indexes can become inefficient because there is a lot of overhead when it comes to writes, as it have to maintain the order. And I spoke about rebuilding the indexes, right? So if it is SQL Server, you can rebuild the indexes using these commands. If it is Postgres, you can use this command to rebuild. Okay. Now, one of the practical example here is the table have only 4 columns, but a developer prematurely created indexes for each and every pattern. For email, he created one index because the user end up searching on email, then created it, then status, then email status, status created it, email created it. So all combinations are used. So this is an example for excessive indexing. You can actually reduce like this, because for this data set, these are the commonly used patterns. The email and status as well as created yet. We typically use the combination of created yet and status to search for the users for pending users, right? So we should be in a position to reduce the number of indexes based on the application usage patterns. So you have to sit with application owners and determine how the usage of the application and how it will impact the tables, and then you have to do the research and come up with the indexes. Okay. And these are the maintenance strategies. As developers, you don't need to worry too much about it. Scheduled maintenance is taken care by DBS. However, you might have to regularly monitor to ensure the performance of the queries are not degrading. For example, this is a very classic example. Sometimes a query might be performing very well for a period of time, and after a while, it might be doing a full table scan or inefficient index scan and all. Okay. So that can be caught using regular monitoring. Why such kind of things happen? Probably the indexes are not rebuilt regularly, or the statistics are not computed regularly, or there might be data quality issues, right? If a query is running consistently well over a period of time, and suddenly if the performance is degraded, you have to troubleshoot and see why it is performing in that manner, and then you have to take it forward. Now, here are the best practices which you need to follow before creating new indexes. You have to check existing indexes, analyze the query patterns. This is the important one. You have to sit with business users and analyze the query patterns, or understand the requirements and go to the query patterns. Sometimes you might have to negotiate with the business users also, saying this is not appropriate way of building the application. We have to change the user experience. And then if they agree, then you have to update the design, and then you have to implement. Okay. And you have to consider impact on writes when you take care of indexes on the tables. Maintenance windows is typically taken care by DBS. You don't need to worry too much about it. And also, you need to have a data model for your database. And there you might have to track the reasons why you are creating the indexes. Sometimes, even if you don't have the data model, all the databases will facilitate you to create comments on columns. And you can use the commenting feature in the database tables and itself to actually document the reasons why you are creating the indexes on specific columns. That way, someone can do the research and then determine whether they are really required or not, and take it forward. Okay. This will ensure the documentation is properly done, and also you will be able to keep track of the index inventory. So these are the some of the techniques which you can use to tune the performance. Most of the details are around indexes and explain plans. Now, in the next session, probably next Saturday and Sunday, I'll have this session. I will broadcast the message very soon. What we'll be talking about is these ones. So apart from over indexing and maintenance, so we have covered 4 scenarios and setting up the database. It also took a bit of time, right? So we have joins versus subqueries, table partitioning and partition pruning, appropriate data types, optimizing the ranking queries, bulk loading strategies, and parallelism and concurrency in data processing. So these are all very, very interesting topics. Make sure you join the next session also and understand how I have used different techniques to improve the performance. The best results I got are based on the indexing foreign key fields, indexing based on the search patterns, and also optimizing ranking queries. That is also quite often used. And then do yourself parallelism and bulk loading strategies. Okay. Especially the last two are very, very important for data migrations, data engineering, so on and so forth. And keep in mind, even though those are covered using Python, you can leverage these with any programming language or even simple shell scripting, especially from the data migration perspective. So that being said, that's it for now. Thank you very much for joining the session. Once again, I'm reiterating, we are conducting a workshop on data modeling very soon. We'll be sharing the link in the description. If you are interested to sign up for the data modeling session, which will be conducted under $100, feel free to fill the form. And also you can follow up with us through support@itverse.com or by having a comment in this video. We'll take care of sharing the required information and we'll take it forward. Most likely the session will be conducted in March. It will be conducted by a very good friend of mine, Sharath, who is a veteran in the industry with more than 15 years of experience. He works for a high-tech company and he's a accomplished data engineer and he will not be disappointed. Okay. And on top of it, before we wrap up for today, stay tuned for the next session and also make sure you click on the like button if you like the content of the video. If you have any comments to share, feel free to post the comments or use the comment section to post your feedback or suggestions. If you haven't subscribed to our channel yet, make sure to subscribe and also click on notification icon so that you are notified whenever we conduct live sessions like this. Also, we are planning to come up with database specific performance tuning workshops. They might be paid. If you are interested on a specific database, feel free to comment or reach out to us at support@itverse.com. We'll host a specific database related performance tuning workshops as well. That being said, thank you.